semiconductor lasers. Yeah. So in last class we discussed about the homojunction semiconductor laser. So briefly I will explain that homojunction semiconductor laser. Okay, because so heterojunction also same. In case of heterojunction also, so that properties are so whatever how it will be the so total construction working everything will be same. Everything will be same. Only difference is so number of layers. Okay, number of layers is the different. Okay, my screen is visible to you.
Yes, sir.
So this is the so construction of homojunction laser here. So here only homojunction is means so we are taking gallium arsenide both side. We are taking gallium arsenide material. One side we are doping with P type, and another side we are doping with N type. Okay. So because of this doping, so what happened here? So this region will become a N type and this region will become a P type. Okay. Now, so total entire material is here gallium arsenide only. So that's why this type of lasers we will call it as homojunction semiconductor lasers. Okay. So here there are so many main disadvantages. What are the main disadvantages means? So where laser will be emitted? At the junction of the P region and N region, laser will be emitted. Laser will be emitted. Okay, so that emitted laser will come out from the two different surfaces. So this surface and again opposite surface. So we will place here optical resonator. So because of the optical resonator, what happened? So it will be reflect again and again. That means amplitude of that laser will be increases. If you increase the amplitude means automatically intensity will be increases. So what is the relation between amplitude and intensity? I is equal to I proportional to A square. I proportional to A square. A is the amplitude. Okay, so I is the intensity. Intensity is proportional to amplitude square of the amplitude. Okay, that's why what happened because of this optical resonator. So that amplitude is increases. So now what happened because of that same gallium arsenide here and here is same. So that's why what happened. So total if you will take everywhere material, that refractive index is constant. That refractive index is same. Okay, if refractive index is same means what happened here? So that light, whatever light will be there, that light will transmit it at any position. So that here laser light is there, that laser light may goes into the so like this also, above region also, below region also. Okay, that's right. So this optical region, that active center, so that light is not only enter into the active center, it also transmit into the so other regions also. So that's why there is so many chances are there. So that laser loss, so loss of laser, so loss of laser. So that's why for reducing the losses of laser, so we'll take a heterojunction semiconductor laser. So because in homojunction semiconductor laser, so refractive index of the material is same. If the refractive index is same means, so without any without any conditions, that light will enter into the so total entire material. So if that light is entering into the entire material means may chance to so many light is losses, so many light is losing. So that's why, so for reducing this what we are doing here, so we are introducing the heterojunction laser, remaining everything is same working principle, total everything is same. So only Here difference is, in case of heterojunction laser, there are so many types of layers are there. Okay, so here initially, so p-type gallium arsenate, this p-type gallium arsenate will act as a active medium. P-type gallium arsenate will act as a active medium, and above that p-type gallium arsenate, so there are a p-type gallium aluminum arsenate will be there. Okay, again here p-type gallium arsenate, that means in between the two p-type gallium arsenate regions, there is a middle gallium aluminum arsenate will be there. Gallium aluminum arsenate will be there because of here aluminum. So what happened, this refractive index will be changes, this refractive index will be changes. Similarly, in below region, here n-type gallium aluminum arsenate, n-type gallium aluminum arsenate. Similarly, n-type gallium arsenate, so these n-type gallium arsenate as well as n-type gallium aluminum arsenate will provide the electrons, will provide the electrons here. Okay, so these electrons will be in conduction band. Similarly, so this so these three layers, so p type gallium arsenate as well as p type gallium aluminum arsenate, again p type gallium arsenate, so these will provide the holes. Okay, these holes will be in so valency band, electrons will be in conduction band, holes will be in valency band. Okay, now this is the energy level diagram also here given, energy level diagram also here given. So that energy level diagram of p gallium arsenate is this one. So p type gallium arsenate is this one, and so p type gallium aluminum arsenate is this one, and n type gallium aluminum arsenate. So this is the energy level diagram of, so this junction diode. So these are the junctions, so combination of these are different junctions will be there. So main junction is this p type gallium arsenate, so that will act as a active center, active center. So at this center, what is that, recombination process will be occur, recombination process will be occur here. See, so if you after connecting the forward bias, after connecting the forward bias here, so this will act as a so active center. So this p-type gallium arsenate, if you will take, this is the n region, so n region contains conduction band. So after connecting the forward bias, what happened, so that forward bias overlapped, that forward bias, so that means into the enter into the depulsion region, forward bias enter into the that means that conduction band enter into the depulsion region. So that conduction band electrons also enter into the so so this p-type gallium arsenate conduction band. Okay, similarly, holes will move, so moves into the, so this p-type gallium arsenate valency band. Okay, so recombination occur in between, so here in that p-type gallium arsenate region. So because of this recombination process, what happened, same, everything is same here. So previously how it will be there, same process. So one initially, so what happens, spontaneous emission will be occur. So because of the spontaneous emission, one photon will be emitted, one photon will be emitted. Because of the optical resonator, because of the optical resonator, what happened, so that photon will be again reflect back, so it will strikes the, that means it will trigger the, so that conduction band electron. Now so incident photon as well as, because of the electron jumping from conduction band to valency band, so another photon will be emitted. Now total two photons, those two photons reflect back, so again, so those two photons trigger by the those two photons triggers the another two electrons. Now total four photons will be emitted. So this process will be did again and again. So after certain time, so what happened, one side there is a partially reflected mirror. So because of that partial reflected mirror, so after getting the sufficient intensity, so that laser will come out, laser will come out. Okay, so now, so what is the use of these lasers? So here refractive index is different for different layers. See here, so this is p, here laser will be emitted, so laser will be emitted, that laser does not enter into the, so this p-type gallium aluminum arsenide, because here refractive index is different of p-type gallium arsenide. So because of that different refractive indices, what happened, so that laser does not enter into the so above region as well as below region also. Okay, that's why so only laser contain, so at this part only, that's why laser does not enter into the so throughout the material. So that active region is so only configured to particular region. Okay, so because of that reason there is no loss of laser. Because of that reason there is no loss of laser. So this is the heterojunction laser working. Okay, so remaining all process, so pumping mechanism, lasing action, so those all are same. So main drawbacks of homojunction is the active region is not well defined. Okay, so but here that active region is well defined, because only that active region contain p-type gallium arsenide only. Okay, and now so one more drawback in homojunction is, so the semiconductor has, so that homojunction semiconductor has nearly uniform refractive index, so throughout the material, therefore light can diffuse from active layer into the surrounding medium. Okay, so that's why in case of heterojunction laser, so here refractive index is different. So here refractive index is different, here refractive index is different. Because of different refractive index, so that laser does not enter into the one part of material into the another part of material. So that's why that laser contains only in active medium only. Okay, that is the main use of heterojunction laser. So that's why there is no loss of laser. So this is about the heterojunction laser. So remaining everything is same, only you have to write. So to overcome the drawbacks of the homojunction laser, this was prepared, this heterojunction was prepared. So here how to overcome means, so we are doping with the different layers. So we are making this heterojunction laser, so by using different layer of the material. Okay, so this is about the heterojunction laser. Now coming to the, so this CO2 laser is not in our syllabus. Okay, so that's why no need to read the discussion about this CO2 laser. Now ND ag laser also not in our syllabus. Okay, so that's why this is also no need to discuss. Now coming to the importance of laser or applications of laser. So here importance of laser, so this laser will be used in so medical field and defense field, so and scientific and research fields. Okay, scientific and research fields, how it will be useful. So lasers in communication, so main applications here, lasers in communication system. Okay, so already we know that how it will be used in communication system. So just read once. So radars, so many communication system will be there. So in those communication system we can use the lasers. Okay, now lasers in industry, so in industry also we'll use the lasers. So suppose if you want to use the joints, so welding, so suppose if you will use the normal gas welding, so that will be spread so much distance. So while welding, so by using normal gas welding, so what happened, so much of material will loss, okay. But if you will take laser welding, so laser welding means at a particular region whatever we want, so we can focus laser that only that part only. So because of that what happened, so only that part will be melt, and we can fix the welding easily. Okay, that is the main advantage of this laser welding. So yes, like that so many applications will be there in industry also. Okay, now so these all are the, so what is that cutting and different shaping of the material. So these all will be there, that is those are the industrial applications. Now in medicine also so many applications will be there. So eye surgery and uh, stomatology and tattoo removal, So these are the some applications in medicine. So many application are, so some more applications also there. So those are the throat cancer, and so therapy for throat cancer, so used to open heart surgery, artery surgery, okay, and destroy the kidney stones. So like that, so many options are there. And military applications, so suppose by using laser we can destroy the here drones, okay, other heavy objects also, okay. And here laser guns, we can use the laser guns. And so LiDAR. So LiDAR means, suppose we can measure the object, width of the object. So width of the object. So in LiDAR applications also we can use how to how to apply the LiDAR means, so from starting onwards they will produce the two lasers. So by using two lasers, so two lasers they will apply the lasers. So they will increases the angle of those lasers. Those increases the angle of those lasers. So at a particular angle, what happened, that object will be, so, what happened. So suppose I will explain you by using diagram. Yeah, so here there are one object will be there. So here one object will be there. If you want to measure the width of the object, width of the object, so by using LiDAR application, we'll find out the width of the object. How to find out the width of the object means, so by using, so two laser lights. So gradually they will increase the initially, so angle between those, so their angle will be there na, that angle between the these lasers will be very less. So they will increase the angle at a particular angle. What happened, so these lasers will out of the object because of that reason. So based on that, so they will find out the what is the angle. Based on that angle they will find out the width of the this object. They will find out the width of the this object, like that. So in LiDAR applications, so they will find out the width of the object. So suppose if you want to measure the radius of the diameter of the moon, so we can use this technique. Suppose so very objects, the asteroids, so asteroids will be there. Suppose if you want to measure the width of the asteroid, okay, we will use the lasers. So this, like that, okay. So lasers in computers also they will use. So here while using reading and writing of the disks, hard disks, so like that, and printing, laser printing also they will use. Okay, so many other applications, nuclear fission applications also they will use lasers. And scientific and research, okay, so microscopic objects, so scanning of the microscopic objects will use the lasers here. Halogram, so halography, also, so we'll use the lasers. And fingerprinting technology also will use the lasers. These are the some applications of the laser. Okay, now we'll discuss about the, we'll go to the fiber optics. So fiber optics topic. So because our time also very less, we have to complete the syllabus on or before third. Okay, that's why, so fifth units also there, that's why we'll complete as early as possible. Okay, so I think only some people sent to the this third unit assignment. Okay, already I noted whoever sent. So some people today also, some people sent. Okay, I noted those persons also. So remaining people, if any will be there, send today only. Okay, now we'll discuss about the fiber optics. Because while I am saying like that means, so the third unit is so important. Okay, so that you, if you perfect, so third unit total means you can answer the two questions. Two questions means total 28 marks. You will get the 28 marks if you read perfectly in third unit. So you will get the 28 marks. Okay, so that's why I am saying so, because the topic also very small topic. Okay, now coming to the, we'll discuss about the fiber optics. So fiber optics. Now, so where we will use the fiber optics? So in communication system, mainly we'll use the fiber optics in so transmitting the electrical signals. So first of all, those electrical signals we have to convert into optical signals. So we'll transfer the optical signals by using so these optical fibers. So in communication system we'll use the optical fibers. Okay, so how to use this means first of all we'll convert those electrical signals into optical signals. So through optical signals we will transport those optical signals into optical cables, fiber optic cables. Okay, because of this fiber optics what happened, so losses will be very less compared to so that means so many air through Wi-Fi and other so many other systems also we can transmit the electrical signals, but in those signals what happened, so there is so much loss of data or strength of the signals also. But in case of fiber optics so there is losses will be very less. Okay, we will discuss briefly about that. Yeah, first of all, so in this fiber optic system mainly we will discuss about the introduction, principle of optical fiber, acceptance angle, acceptance cone, numerical aperture, type of optical fiber, step index and grade index optical fiber, attenuation in optical fiber. Attenuation means losses in optical fiber, and applications of the optical fiber. Okay, first of all we'll discuss about the introduction. Okay, fiber optic is a technology related to transportation of optical energy in guiding media, uh, specifically glass fibers. Okay, so here we will use the glass fiber to transport the optical signal. Guiding is nothing but transmitting the light. Okay, light energy. Okay, now coming to the optical fiber is long, thin, transparent dielectric material. Okay, which carries electromagnetic waves of visible and IR frequency from one end to other end of the fiber by means of total internal reflection. Okay, so optical fiber. So what is the fiber? What is the definition of fiber means? So compared to the diameter, so length diameter ratio. If you take length diameter ratio, so that the length diameter ratio is very high. That means length is very high compared to the diameter. So like that material, whatever it will be there, so we will call it as fiber. Okay, so what is the fiber means? If you will take the length diameter ratio, so that will be very high. Length diameter ratio is very high. So that type of materials we will call it as fibers. Here optical fiber. Optical fiber is nothing but so because so in that fibers, so optical signals are transmitting. That's why we will call it as this is the optical fiber. Okay, so this is a thin transparent dielectric material inside. So inside that optical fiber there is a transparent dielectric material will be there. So through that transparent dielectric material only here optical signals means em wave. What is the range of em wave? So x-rays all, so x-rays, ir rays, uv rays, visible rays, so these all rays we will commonly call it as electromagnetic waves to transport the electromagnetic waves. So we'll use this optical fiber. So here mainly we'll transport the IR radiation as well as visible radiation. Okay, so in that EM waves, so mainly we will transport the here visible and IR frequencies. Okay, by using what is the principle here? How in case of optical fiber, so this is light is transmitted. That means by using total internal reflection here. So based on the principle is total internal reflection. Based on this principle, so we'll use that light is transported from one end to another end of the optical fiber. Okay, now here glass or plastic is used as a dielectric material. So inside we will use dielectric material, transparent dielectric material. I said that. Okay, so for that transparent dielectric material we will use as a plastic or glass or plastic we will use. Okay, so I will explain you while discussing about the parts of fiber optics. Parts of fiber optics. So I will explain you what is the how it will be useful. Okay, now coming to the optical fiber works as a waveguides. Waveguides is nothing but to transport the waves. Okay, works as a waveguides in optical television signals, digital data to transmit voice television signals, digital data to any desired distance from one end to other end of the fiber. Okay, if you want to transport the digital signals from one end to another end, we can use these optical fibers. Okay, now how it will be transmitted? So this is the EM wave, so transmission of the EM wave. So based on like this, so it will be transmitted. Okay, now coming to the, yeah, so here, see here, electromagnetic waves. So light will be EM wave will transmit based on the electromagnetic waves, na? So that means it like electric field and magnetic field. Okay, now we'll no need to discuss up much more about this. Okay, now, yeah, so these fiber optics is become popular. Okay, what is the reasons? What is the main reasons to so fiber optics will become popular? Because there are so many communication systems is there, not only fiber optics. So there are so many other communication systems also there. So why these fiber optics are more popular? Okay, so main reasons are this one. So here, higher information carrying capacity. So it will so carries the high information, light in weight, small in size, and low cost. Okay, so lightweight, small size, and low cost. And no hazards of short circuit, and can safely used in explosive environment. Okay, there is no hazardous, and it will be safely used in explosive environment like short circuit. Some situations, if you use electrical wires, so because of may chance of the short circuit may damage. Okay, like that situations, so if you use the optical fiber means it will be very safety. Okay, now coming to the no possibility of internal noise and cross talk generation. There is no internal noise, so there is no internal noise if you use the optical fibers. Okay, and see here one more important point: using an optical fiber, 15,000 independent speeches can be sent simultaneously, whereas using a pair of copper wires, only 48 independent speeches signal can be sent. Okay, suppose casually in loudspeakers, so how to transport what is that audio signals from so your system to loudspeaker? Generally we will use the what is that copper wires. Generally we will use the copper wires to transmit the so that audio signals or video signals. So by using, generally we will use those copper wires. But if you use optical fibers, means, so we can send 15,000 signals, 15,000 signals at a time through one optical fiber. But in case of normal wires, normal copper wires, only we can send only 48 signals, 48 different signals. So in that also may chance to overlap of the signals. Okay, this is about the main importance of optical fiber. Now construction of optical fiber. Okay, construction of optical fiber. So if you see the observe the optical fiber mainly consists of the so these six parts. Optical fiber mainly consists of the six parts. So what are those parts? So first one is core, cladding, silicon coating, buffer jacket, strength membrane, outer jacket. So these are the main six parts of the optical fiber. So first one is the core, second one is the cladding, next one is the silicon coating, next one is the buffer jacket, next strength members, so next outer jacket. Okay, so these are the main important parts. So what is the those uses? Okay, now center, at the center, so core will be there, present at the center. Typically glass fiber consists of a so central core of thickness just 50 micrometer, surrounded by cladding. Okay, generally we will use the So glass material. So in case of some type, we can use also plastic also, but more cases we will use as a so glass material. Glass material used as a core material. Core material. Okay, its thickness is very small. Its thickness is very small. Generally, just 50 micrometer. 50 micrometer. Next one is that, and it is surrounded by cladding. It is surrounded by cladding. Next one is so cladding material. So cladding is of a glass of slightly lower refractive index than the core refractive index. Okay, that means if you will take here cladding material also glass material, cladding material also glass material, same whatever. Suppose in core we are using silicon. Silicon is a so silicon glass we used. Okay, in cladding also we'll use silicon only, but refractive index is different. Refractive index is slightly different. Okay, slightly different. That refractive index is lower than the core. So cladding diffractive index is lower than the core refractive index, which is overall diameter is 125 to 200 micrometer. So this diameter is just 50 micrometer. So cladding diameter is just 125 to 200 micrometer. Both the core and cladding are made up of same glass, SiO2. SiO2. SiO2 means silica. Here, silica glass. Okay, and put to refractive index of cladding lower than the refractive index of core by addition of some impurities like boron, phosphorus and germanium. Okay, so that means how to change the refractive index here means, so in case of cladding material they will dope with another materials. So that cladding material also prepared by using silica only, SiO2 only. Okay, SiO2 generally we will call it as silica. Okay, so that silica material only. So by changing the refractive index, just we will dope with boron or phosphorus or germanium. Okay, so this is about the cladding. Now, so and again on the cladding, there is a silicon coating is there. Silicon coating is there. It is provided between the, yeah, 1 minute. So it is provided between buffer jacket and cladding to improve the quality of transmission of light. Okay, so after cladding, so on that cladding there is a silicon coating is there. Silicon coating. So why they will use silicon coating means, so here in that so after entering the light, what happened in between the core and cladding, so the total internal reflection will be takes place. Because of the total internal reflection, so all light enter into the again core only. That means all light transmit through core only. If any light will be losses, if any light will be what is that jumping from the core, if any light is losing from the core, so that will be again reflected by the silicon coating. That silicon coating, because of the silicon coating, what happened, we can reduce the losses, we can reduce the transmission losses, transmission losses. That's why quality of the transition will be increases, quality of the transition because of the silicon coating. So what happened, so we can increase the quality of transmission. Okay, next one, so buffer jacket. So that silicon coating, where is the silicon coating means, it is in between the cladding and buffer jacket, cladding and buffer jacket. Now buffer jacket over the optical fiber is made of plastic and protects the fiber from moisture and absorption, sorry, aberration. So aberration means there is a reduction of material. So there is a loss of material. So ఏదైనా రబ్ అయిన, suppose if there is a rubbing will be there, because of rubbing there is a losses will be there. So because of that rubbing, so there is so many losses will be there. So to protecting the, so that losses, uh, we can use the buffer jacket. So we can also use so there is the to protecting the moisture, to protecting the moisture. Okay, we can use the buffer jacket here. Okay, so main use of the buffer jacket is so to protect the this clad core and cladding, to protect the core and cladding Okay, so how to protect means this is a buffer jacket and it is a plastic material. So it is a plastic jacket material. Okay, now so it is protected from moisture and aberration. Okay, and next one is members. What is the use of strength members means in order to provide the necessary toughness and tensile strength. Okay, a layer of strength member is arranged surrounding the buffer jacket. Okay, suppose if you apply the any tensile strength, suppose if you pull the fiber optics, means what happen, may chance to break because glass is very brittle. That's why, so if any pulling will be there, may chance to break the glass. So that's why, to protecting the those core and cladding, so we use the strength membrane. Okay, next one is the outer jacket. So outer, finally the fiber cable is covered by the black poly urethane outer jacket. Because of this arrangement, fiber cable will not damage during hard pulling, bending, strengthening, or rolling through the fiber is. So because fiber is generally inside core cladding material is made up of glasses, that's why it is very brittle. Okay, to protect the core, so again one more protecting layer will be there, that is the outer jacket. Okay, yeah, I'll explain you briefly again here. So this is the cross sectional diagram of the optical fiber. So inside there is a core will be there. So that core, radius of the core, diameter of the core is just 20 micrometer to 50 micrometer. And here cladding material. So this diameter of the cladding material. So what is the use of cladding material means, here refractive index of the core and cladding is different, but so both are having same material, both are prepared by using same material, that is glass SiO2 material only, but refractive index is different. Why refractive index is different means, so that cladding material is doped by either boron, phosphorus, any other material, germanium. Okay, because of the doping, so this refractive index will be decreases. So that means refractive index of the cladding material is lower than the refractive index of the core material. That's why what happened here, so when light is enter into the denser medium to rarer medium, denser means here refractive index is more, here refractive index is less. When light is enter into the denser medium to rarer medium, total internal reflection will be takes place, total internal reflection will be takes place. So that's why here there are two refractive index of core and cladding is different. Okay, again on that core material, on that cladding material, there will be a silicon coating will be the silicon coating. So this silicon coating protect the if any light will be losses, if any will be, so some light may, so the total internal reflection also depends on the angle of incidence, angle of instance. If the angle of incidence is greater than the critical angle, then only total internal reflection will be there. If any light is if any light angle will be lesser than the critical angle, what happen, so may chance to that light enter into the cladding. Okay, so because of what, that's why what happened, what we are doing here, so we made here silicon coating. Okay, so because of that silicon coating, what happened, that silicon coating again reflect that light into the core. Okay, that's why, so there is a less losses, transmission losses, there is a less transmission losses. Now buffer jacket, so this buffer jacket, protect the, so this optical fiber, so protect the optical fiber from moisture and what is that uh, abra- what is that aberration will be there na. Aberration is nothing but rubbing losses, any material loss due to the rubbing, that is the aberration. Okay, next one, strength members means it will provide the tensile strength to the optical fiber. And so the final one is the polyurethane outer jacket. This polyurethane outer jacket provide the, so tensile strength as well as so bending strength, so many so ways it will be useful. This is about the different parts of the optical fiber. Okay, so today we'll complete. So here next class we'll discuss remaining topic. Okay, So first of all, I will take the attendance. If you have any doubts, you can ask. Yeah. So otherwise, you can leave from the session.
Thank you,
Any
sir.
doubts? Yeah. Okay.